Okay, my testing 1, 2, 3. Okay, next after the break, we go into. We already completed rectilinear motion, which is in straight line. Now we go into curvilinear motion. So the word curvilinear means is in the curved path. So again, we will still be using position, velocity, acceleration in a vector. So in the canvas already up. Do I give you appendix B? Okay, remind me if I haven't upload appendix B into the canvas. Is a revision material on vector analysis. Mean what is the dot product, what is the cross products, what is the steps of analysis if you see cross product, dot product. Okay, and I assume you already passed the mathematics, so I will not go deep into calculation, right? So I will not answering question on how to do vector, how to do dot product. I assume you already know. Okay. So first, we answering the question or definition of position. Since we are in the curvilinear, so in the curve form, then we put into one particles, and it will slides along the curve. So for curvilinear, the blue line, I will use blue line in my slides. So one position to another position, we denote as S bracket T means is in the function of time. Your position is in the function of time. Okay. Then since it's a curve is actually circle. So circle, you know you have a radius. For curvilinear motion, if you have this curve, where is the R? The R will always pointing inside the curve. You have this curve, the R is pointing inside the curve, not here. Okay, so when you do position positive, negative, also be careful. Don't put the wrong side. Okay. So your R equal to R bracket T also because it's changed with time. We note with our initial position 0 or the center of the curve. So we have the first position vector R for curvilinear motion. R is your position. Then it's a vector form. Huh? Vector means have magnitude and direction. Displacement is something happen between the time. In this case, we use delta R. Show you the position. So from R origin to R prime. From R, this is a position. In curvilinear motion, always define the center of the curve. From where to where? First location R, second location R prime. From straight line, you know this is vector. The yellow or orange color arrow is a vector. Vector 1, vector 2, you combine two vector, you get product of vector delta R. Again, if you forget what is vector, go and see appendix B or flip your mathematics textbook. Go and see how to find the resultant of vector. A vector you can break into two small vector. Let's say this is V, We have Vx, Vy. You can draw in vector diagram. Vx plus Vy, you get resultant V. This is the first vector diagram you learn in your maybe in your statics. So we have our first equation for curvilinear motion. R prime equal to R plus delta R. This is a vector diagram where V equal to Vx plus Vy, for example. What does it mean? Vx plus Vy. Final position. Final position equal to initial position plus the change of position. Make sense to you? So you write in the formula, R prime equal to R plus delta R. First equation for curvilinear motion. And this is the position, R prime. Again, in previous rectilinear, we have position. Here also we have position equation, R. So we vector. Don't see it as numbers. Out here is not you need to consider two components. One is magnitude, one is direction. Okay. I go a bit fast for this second session. So again, we go into velocity. Velocity, linear motion equal to ds over dt, or time differentiation of your displacement. Here also same, you replace the displacement with delta r. V average equal to delta r divided by delta t. Again, this is average. We're more interested in instantaneous velocity. All right. So same. You change from average velocity into instantaneous. Time. So the triangular delta you change to ds dt. Sorry. It should be dr dt. Then you know in your curve equation, this is a curve. For this curve or distance travel on the curve will be so we can write the r equal to ds in terms of half. So it means we equal this change of red color delta r with the same blue color half. Make sense? Means if the angle very, very small, then this distance will same almost same as this. This one we change, we see it as a straight line. If it's very, very small. Okay? It's what you learn in this mathematics. Right. So this is the second equation that you need to learn. This is the first one. Second one is the velocity equal to v dr dt equal to ds dt. Then again, this is vector. Vector have magnitude. The magnitude for velocity we call it speed. Okay. So I draw something on the curve on the diagram here. So the green color is your velocity. What does it mean? Every time you draw a curvilinear motion, you want to look at that particular time from the radius O, from the you have a velocity vector tangent to the curve. Okay, always works, this one, when you look at velocity. Of course, here we haven't touched on the direction yet, but early information I feed to you. The direction when you draw on a curve is always tangent. You know tangent, right? If you draw this vector and this R line, it always 90 degree. So you have a ruler. Ruler, you know your ruler is sharp edge. You just place your ruler on your diagram and then draw the line. Okay. So throughout this chapter 1, velocity I'll use green color. So you don't confuse, Okay. Next, we look about acceleration. Acceleration in linear motion. What does we learn? Acceleration equal to dv over dt. Same. You use the same, but this is curve. So curve at a equal to t. Now t no longer 0. We are more interested in that particular time change. So at t, then it will slide. At t velocity, you have a velocity. And then what mean by acceleration? Means that the change of velocity. Change of velocity means we look at another time. After a certain time, means t plus delta t. Make sense? Then you need to draw another velocity for that particular that particle. And just now I told you how to draw the green arrow, right? You place your ruler, draw 90 degree to the center of this curve. Okay. Now just a quick pop quiz, Just a quick pop quiz. Just think, I'll draw something on the whiteboard. If this particle move in this motion, you can break this curve that I draw on the whiteboard here into two curves. Where is the center of this first curve? Top, This is your left to right. So where? Okay. Now, when you draw arrow, if accelerate means your velocity increase, and you in your vector chapter you learn So in this case, on the diagram that you see on the screen here, it means the particle accelerate, become faster and faster, right? So in your answer, in your assessment, be careful on the line length that you draw. Of course, when you solve question, you you can use the same length when you solve first, the first steps. But when you continue to solve that answer later on, the question will tell you the particle accelerate or decelerate. So on your solution, when you draw diagram, especially when it comes to vector, be careful on the length of the arrow that you draw. Be consistent. So if the question tell you is accelerate, means the first velocity will be shorter than the second one. Of course, you draw the same length also okay lah, but don't draw shorter if it's accelerate. Okay. So again, we use the prime means the second velocity. Okay. So move back to the definition of vector. When there's a change of velocity, v prime, there must be a changes of something. So v prime equal to v plus delta v. There's a change of velocity there, right? So again, this is vector. Means this vector equal to original vector plus another vector. But that is differentiate towards time, not divide, differentiate. So instantaneous also same. Instantaneous also same. So and by right means delta v equal to the last velocity equal to initial velocity, or final velocity minus initial velocity. Okay. So I copy the vector diagram, the vector arrow. Copy, I put here. I copy, I put here. This is a two vector. So we need to recall how to solve these two vector. You need to draw a vector diagram. So this is initial. This is the final. So you, by using this equation, you join the arrow from here to here. Okay. So we will put on your answer solution in your assessment. You put in original position. O means O prime means there is a imaginary center. It's not related to what happening in the real scenario, but because you are pulling the vector out and you put them together. So you put on the imaginary center, I mark as O prime. Okay, it's not this O prime, O comma is not same as the origin of the circle. It's not same. This is prime means imaginary. Okay. So when you put these two arrows on an imaginary dimension, then these two vectors actually pointing on the imaginary curve. Because this motion move in a curvilinear motion. So you combine these two vectors from a center, that imaginary, and also in the curvature form. We call it a technical term. If you study mathematics deep enough, this is called hodograph. And then this is hodograph. Then you join the arrowhead to arrowhead. I label as yellow color. Yellow color is your delta v. Means it's the differences of velocity vector. Okay, so here is one of the vector diagram. Vector diagram. So you do the same. Okay, you do the same. So how about instantaneous? Same, you do the limitation process. You put a limitation, t delta t 0 means you freeze the velocity at that particular time. It will become acceleration equal to differentiation of velocity towards time. Make sense? So this is the second one. So I highlight on the screen there. So you can transform this diagram into another hologram diagram that you see on the screen there. I label as yellow color arrow A. And this A do not same as velocity. Just now velocity, I told you that velocity is a tangent 90 degree. However, acceleration, no specific direction. But you have to find where is the direction. Okay, so it doesn't necessarily 90 degree. So don't confuse with the acceleration vector direction. Many students, they will assume this A will same with the V. No, so don't make these mistakes in your answer. On the hodograph, yes. On the hodograph, is yes, but when you solve problem, usually you combine velocity and acceleration together. So don't use this hodograph on the real analysis diagram. Okay, so here, this is a path, blue color, and so you have a path, V, and acceleration. Okay, V towards this path. So acceleration always pointing towards inside the curve. If you there's a two different diagram on the screen here. One is on the far right. This is on the hodogram. Usually we don't use hodogram, but we will use this diagram on the center of the on the screen here. So there are two ways of drawing velocity and acceleration. Acceleration always pointing towards center of the curve. Okay, so there are two skill set here. One is V, one is A vector. Important. This skill set today onwards, you should know when I ask you to draw a velocity on a curve. If you move from the left to right, then it's this direction. If you right to left, then it's that direction. And acceleration always pointing inside towards the curve. Not outside the curve. So important, this one. Because in and out, it will tell you the answer is whether positive or negative. Okay, so this one is your assumption in the early stage. So here, yeah, so V equal to dr dt. So you can write your acceleration same. In your linear, you use A equal to differentiate your so you change the the S into R. So dV equal to A equal to dV, second equation for curvilinear, A equal to dV dt. Also, when it's curvilinear, no longer see S, but is R dt differentiation 2 times. Okay, so we are just stepping a little bit on what you learned previously. Add on. Okay. Now, because curvilinear motion curve is sometimes very complex, we want to define it in the coordinate system. Next one, we put into rectangular component. It is in the Cartesian plane. So Cartesian plane means you have x, y, z coordinate. So position, when you on the screen here, you know that when you have position, you have x, y, z. And when you deal with vector, you use the vector identity. for z direction. Make sense? This is what you learn in your mathematics in vector form, in vector chapter. Okay, so if the blue means the path lah, S means the path, and let's say these particles, when you look at that study, that particles, you freeze that particles, and you can define the position by using vector form r equal to xi plus yj plus zk. Make sense? Then from here, you recall what you learned in your mathematics to find the magnitude of the vector, which is the square root of x squared plus y squared plus z squared. How to find the angle? Later I'll show you on the screen. There's a formula that you learn in your mathematics. Just recall what you learned in your mathematics. Okay, so there's a different form of writing vector. In my slides, because it's very troublesome to always give the arrow on top of the vector identity, I will just highlight it and bold it in my slides. So every time on the slide you see I, J, and K, or italic bold, then it's a vector. Okay, so in that is a vector. Because why I don't use a arrow? Sometimes when you print something, sometimes the arrow is missing. Then you confuse, right? Direction of R specific by unit vector. How to find unit vector? You take position divided by magnitude. This is position. You take this one divided by this one. This is what you learn in the vector, right? So again, you have magnitude and direction. So how to find direction? Direction you already have I. And direction given by direction is position divided by magnitude. Okay. First is position. Now what about velocity? Velocity of the particles. Again, you should understand why the green arrow in that certain direction. This is a curve. Curve always have a center, although the center was not shown on the screen, but the green arrow always 90° from the center and the curve. Okay. So V equal to dr dt, or differentiate of your position towards time. A curvilinear position is R and no longer S. So when you solve question, you look at that, it will tell you that, and you see curve in the diagram. You know already you cannot use S in your solution. You must change to R. Okay, so R equal to d dt, and R is xi, yi, zk, right? What I mean by this is xyz is a rectilinear coordinate. Is a rectilinear, is a triangular things. Can you predict the next steps? X dt, what do you get? Dx dt, what do you get? Previous section. Velocity acceleration. How do you define velocity in rectilinear? Velocity equal to ds dt. But here is rectilinear. ds dt means the change of position in x direction. Means you can replace with Vx. Make sense? Makes sense. Vx means velocity in x direction. Y also. You can replace by Vy. You take position of y, differentiate with time. Position of z, differentiate by time. So these notes also have, okay. Before we go into that, vector operation, d dt xi, because this is vector with magnitude and direction. So when you differentiate, you need to do a product differentiation. Product differentiation, how do you do? You take the first one, dx dt remain the vector form, plus remain the x and differentiate the vector identity. Means you hold one, differentiate, plus hold one, and then differentiate. Okay. Now, based on these products, there is a change of x. Is there a change of I? No, because I is x direction vector identity. So it always constant along the x. So there's no value for second component. Make sense? Apply the same for yj and yk. Okay. This is a long, if you do differentiate, this is a long calculation, but you take out the second component for k, you arrive at this one. So you can write v equal to vxi plus vyj plus vzk. X differentiate by t is a change of velocity, change of position, but also velocity. Right. Velocity in x, velocity y, we're going to check. Okay, then on your diagram, always write the vector form. V equal to something I, something j, something k. Okay. Then magnitude. How to find magnitude just now? This one square, this one square, this one square, square root. How to find the direction? Position divided by magnitude. Okay, good. Excellent. Okay. We have done position, velocity, and acceleration. Acceleration, repeat the same process. But looking at this diagram, where is the this particle, where is the direction of acceleration? Go inside. Okay. So acceleration, same, a equal to dv dt. This is dv, right? So you take different velocity in x direction, differentiate over time, you get acceleration in x direction. Same with y, same with z. Okay. Same, there is a long process just now. There's a product. But I remains same, j remains same, k remains same. We take out, we arrive at this equation. So in short, we can write a equal to axi plus ayj plus azk. Make sense? So today, second half, you already see in a vector form. Okay. Okay, so this is still pointing inside, but it depends on the curvature of this one. It can be inside or that one, but you need to find the center of the curve. Okay. All right, so still same, to find the magnitude, square this one, square this one, square this one, square root. Find direction, take direction divided by magnitude. Position divided by magnitude. Okay, Make sense? Huh? Okay. Again, note here, it will not same as velocity for acceleration. It's not tangent, but it's inside the curve. Let's do this tutorial. So if you have a balloon that mounted on the top of the building, and this cable here is a extendable cable, and the height of the balloon give you by a quadratic equation, y equal to x squared divided by 5. Again, location was given to you, axis x and y. You have point A and point B. So when it start flowing the balloon, you are given the initial distance from the tip of the roof. X is 4 meters, y is in quadratic equation. Okay, now let's look at the question. It tells you that there's a weather balloon given by x, defined by x equal to 2t meter. Means x changes with time, but initial position is 4. So next second, you need to use the linear equation x equal to 2t. T in second, and if the equation of the path y equal to x squared divided by 5, determine the magnitude and direction of the velocity and acceleration when t equal to 2 seconds. So this question, what we have derived just now, right? The definition of position, the definition of velocity, the definition of acceleration. Okay, velocity. How do you find velocity? We have y and x. How do you put them in position? Velocity equal to dx dt plus dy over dtj plus dz equal to dtk. So this general equation will give you 3 marks. Huh? So when you solve question, always give general equation first, then only substitute value. So v equal to x component, y component, z component. We assume this case z doesn't change because z is not given. If it's given, then you need to solve z. But this one is a 2D scenario. In real case, it won't happen. There's a change of z in real case. Okay, so you can either write the first one or second one, both meaning the same. But it's better to write both lah, because later you want to speed up, you can just straight away use Vx equal to something. Okay. So in this case, we don't have z, so we only need to solve 2 components. What is the velocity of, what is your Vx? Can you, based on this equation, what is your Vx? Vx equal to dx dt, right? So what mean by dx dt? You differentiate your x with time. What do you get if you differentiate this one? 2t become? Differentiate, not integrate. Differentiate is what? Minus only 2. Okay. So your Vx, you differentiate your x. This one, you give you 2. What is your Vy? Differentiate dy dt. Take this one. Do you have t here? You don't have t here, but is there any other information you can substitute? This one. Put this one here inside x. Do the rearrangement. You will see y equal to something t. Then you differentiate. Okay, so dx Vx equal to dx dt. So you pull this one, you get 2 meters per second. Do the same for y. And where is the direction of x? Blue arrow. Huh? So start from today onwards, your answer will give arrow behind your answer. Okay, you write an arrow positive. So this one, x is positive this way. So in your answer, you draw blue line. To the right is positive. Okay? Okay, dy, you do the same, but again, this time you substitute. You substitute with t. Do lah, differentiate. I will not go into detail already. You get 8/5t. What is the direction? Going up, huh? Okay. Remember, now you have a direction already. In previous example, actually, you should also put the arrow also. But I won't feed you with. Now, you know that when you solve vector, you need to have magnitude and direction, plus the unit. Of course, here you still don't need to give unit yet. Only the last answer when at t equal to 2 seconds, you substitute, then only you give the magnitude. So you have x and y, you write in the vector form. So you substitute t equal to 2 seconds, you get 3 point something. For this module, minimum 2 decimal place, maximum 3 decimal place. Okay. So so why does the Vx at 2 seconds equal to 2? You understand my question? Vy you know lah, Vy because you substitute t is 2 seconds ma. But why Vx you don't need to substitute? Because he tell you yeah, because the equation don't have t, means that it constant velocity towards the right. There's no influence of time for your Vx. That's why you don't need to substitute. When you have constant velocity, what happened to your acceleration? Acceleration equal 0. Huh? So these are all the free information. Magnitude, you square and then square root. Substitute value you have there. Z we don't have. So the final answer is 3 point something. This is magnitude. Direction. You take position divided by magnitude. Okay. So here, you need to go back to your diagram. Draw where is your x, where is your y vector. You need to start updating your diagram already, since from today onwards. So you are finding vector Vx, you need to go to the position B, draw Vx arrow, draw Vy arrow. Since this is a vector, the direction will be this way. Okay, combination of this one plus this one, you'll get this vector. Okay, na? Nico, okay, all right. So this is the angle from x-axis. So in this case, direction is tangent to the path. Y tangent to the path. Y tangent to the path. Because velocity always tangent to the curve. V there, right? Okay. So this is a, you know, a rectangular, right? This is trigonometry because it's 90 degree. This is a right angle triangular. So you can use tan, cos, sine, depending on your parameter that you have. In this case, you have your A and B. It's a tangent relationship because I is opposite and side. You use tangent theta equal to b divided by a. You flip the tangent to another side, you get this equation on the screen here. Answer, you substitute, you get 58 degree. Okay. What about acceleration? Same. Acceleration, you write the definition of acceleration, a equal to dv dt. What is your dx? 2. When you differentiate 2, what do you get? Differentiate 0. There's no t for you to differentiate. What happened to your y? What is your acceleration in y? You differentiate towards t, 8 divided by 5. 1.6 meter over second square. Remember the unit. You can find the magnitude. Square, a square, y square plus z square. You don't have z, and you have square root. Substitute, you get 1.6 meter over second square. How to find the direction? Okay. So same. You go to point B. X you know is this direction. Y in this direction. Again, this is a 90-degree axis. 90-degree vector towards each other. So you can still use rectangular trigonometry to solve. You have this vector plus this vector. You'll get this one plus this one. So resultant force is this one. Right? This is 90-degree, right? Theta. Resultant vector is from x-axis. So this vector and this vector, there's an angle. So this is a tangent relationship. A divided by B. Vector. This is a very straightforward scenario. And the equation I showed you just now is a more complex one, where you direction you take position divided by magnitude. Okay. So same, in this case, it's straightforward. It's a 90-degree cases. So in this case, you know is 90-degree. Why 90-degree? Because your A don't have magnitude. You only have one magnitude go up. So it's 90-degree from the horizontal axis. When you mention 90-degree means it must from somewhere, from a reference point. It cannot be stopped at that statement. 90-degree from where? From horizontal axis. Okay. What else? Okay, then you label your diagram AY with arrow A. Means there's a resultant acceleration there. Okay. One more example, then we stop. So you have a plane. Usually this one will be in your assessment. So plane described by behavior y equal to something. This is a quadratic with a positive A, means you have a smiling face motion. Sometimes we just give you one statement and won't give you we'll give you one object image. You need to draw the motion. So in this case, you'll give you x and y. Normally the question will just give you one object and then x, y. Then you sketch the motion. So in this case, it's a quadratic smiling face. Then you write the equation, you move up. So if the plane rising constantly, constant upward velocity, 10 meter per second. This is what constant upward means, your y component only. You know your Vy. Make sense? Determine magnitudes of the velocity and acceleration of the plane when it reaches altitude y equal to 100. You need to find velocity when it reaches 100. Here, 100, you extend, then move down, you need to find your x also. Because velocity in vector form, you need to find x dimension, y dimension, z dimension. This one don't have z. Okay. So you put in the equation in the graph, draw 100 meter, but you can find x position, right? You can find x position, right? Substitute 100 in left-hand side, square root the answer. But square root, you know that you're moving to the right, so it's positive value. Because square root always have negative positive value. Okay, so Vy is 10. So your x is, you substitute value, your x is 316.23. Again, 2 decimal place minimum. So on the graph, you update that value. X equal to something. So next, your y equal to Vt. Okay, so how long it takes to reach 100 meter? Do you know how to derive this equation? Y equal to Vt. Yeah, it's just a simple, how you get displacement and with the velocity. You take velocity multiply by time, right? Okay. So in this case, is your Vy multiplied by time. What is your Vy is 10. You have your y position, right? It asks you to find y at 100. So you have your y, you have your Vy, you can find your t. So the answer is how many seconds? T equal 10 seconds. So you know your time. Okay, you know your time. You know your Vy. You need to use change rule again. You should see appendix C after today. If not, remind me to upload. All right. So y equal to 0.001 x squared. Pull out the velocity definition. Vy or v equal to dy dt, because it's in the y direction. You write Vy equal to dy dt because it differentiate upwards. So you differentiate this equation. So you get this equation. Right? So before that, so you understand dy dt equal to this one, right? You need to break this equation using chain rule. You can write this equation with dy dx dot dx dt. It's a chain rules that you learn in your differentiation chapter. Dy dx, you can write dy dt and dt dx. Same with this one. It depends on what you want to find. So in this case, we want to find dy dx dx dt because we have dy dt. Go and read chain rules, how we do. I'll do very fast. So here, if we do dy dx means we take this one, differentiate, we get 2 pull to the front. This one become x. This is dy dx. And then continue dx dt. You will get, this is vx, right? Substitute this one, vx, and you get 0.02x vx. This is a relationship between Vy and your Vx. You know your x position at that particular time. Substitute that x you get your Vx. Vy, you know, always going up 10 meters per second. Okay, so that's why you get your Vx equal to 15.5. From today onwards, you need to use chain rules for curvilinear motion. Go and read Appendix C or refresh your chain rules understanding. Okay. Next, you go to the chart that you draw, update the vector inside the curve, inside the graph. So Vx equal to 15.8, this direction, this is y direction. Again, this is right triangular. If you pull this vector to this one, you get a triangular vector. Triangular vector, again, use back the trigonometry equation. Blah, blah, blah. Magnitude, you know, square root. Substitute, you get 18.7. Direction, you know, is a right triangular. So tangent, you get 32.31 degree. Update this information in the diagram. Draw resultant, draw angle. Acceleration, do the same. I do very fast because our time is almost up. Acceleration, do the same. You have two equations there. A equal to dv dt. You have v equation. So chain rules, d equal, you use this chain rules again. D dt, your vy, because you have two component here. So this is a general equation. So your v is this one, v is this one, and then you do the operation. I don't need to explain this one. You go and study. So let something to something, let u equal to something, v equal to something, you substitute, you do integration. Okay, so this one you substitute and you do integration. So this is your acceleration. Substitute here, substitute here. You have one equation there. Okay, then you substitute value accordingly. You will get a equal to something. Once you get your ax, you can find the magnitude, ax and ay. Acceleration for y is 0 because velocity constant. Okay. Direction, same, 0. Y, acceleration, y, you don't have acceleration in y direction, you only have x acceleration. So angle is 0. Okay, however, it's not this direction. You are doing curvature movement now. So it is going inside. Going inside the curve. This is inside curve. Inside curve. So not this way. So don't draw the. If it's rectilinear, yes. But curvature, no. Curvature have to always inside the curve. Okay, next chapter we look at projectile already. Okay, we stop here. See you after breaks.